Hi, welcome back. Microprocessor online class. In previous video, I explained detailedly about 8086 pin descriptions. Now we are going to see about Intel 8086 microprocessor architecture. First, what are the features for 8086? I already told you in 8086 it is the first 16-bit microprocessor. It was introduced in 1978 and 8086 has 20-bit address bus, so that's why the memory location is 2 power 20, which is equal to 1 megabytes. So it is the range of memory for 8086, and then also it can support 64 input output ports compared with 8085, which is in 8086 is large. It supports more IO ports. And one more important point for 8086 is it contains 14 16-bit registers. Because of it is 8086 as a 16-bit processor, that's why it supports 14 16-bit registers. And word size is 16 bits, because the data can be operated either 16 bits or 8 bits. So the word size is 16 bits. Sometimes uh, the word size is take 8 bits also. And 8086 it has multiplexed address and data lines are there. There are 16 multiplexed address data lines, that is AD0 to AD15, and 4 address lines are there for A16 to A19. So these are all discussed in previous video, that is pin details. There are two operating modes for 8086, that is the minimum and maximum modes. Then it requires 5 volt power supply, that is connected to pin number 20 and 40. Then the range of memory address is 00002 FFFF. Okay, whereas in 8-bit microprocessor that is 0002 FFF. Okay, so here the totally different from, because of it is 20 address lines, so that's why the memory ranges differ. Go to next. This is for internal architecture of 8086. There are two parts. One is bus interface unit, that is BIU. Another one is EU, that is execution unit. From the bus interface unit, it contains uh, a bus interface unit. It contains the microprocessor to connect external devices. It connects external devices. It performs some important operations like instruction to be fetched and reading and writing data of data operands for memory, and inputting or outputting data to other peripherals, and any other function related to instructions and data. For that bus interface unit we can done. Then another one, execution unit. So the execution unit is responsible for decoding and executing instructions. So decoding and executing means it performs some operations like arithmetic, logic, and shift operations. Here some instructions are there for executing arithmetical, logical, and shift instructions. Likewise, the execution unit consists of ALU, status controlled status and control flags, general purpose registers, temporary operand registers. These are all the contents we have to define the execution unit. Before that, in bus interface unit, just you explained how the instruction to be fetched and read, then how the input and output to be transferred to other peripherals, then some of the other related functions to be uh, defined in the bus interface unit. Okay, go to next. Now I explain detailedly for uh, bus interface unit. I told you bus interface unit, it handles some transactions of data and address on the bus. Okay, so bus interface unit, it performs some operations such as instruction to be fetched. Already I told you instruction to be fetched, the reading and writing operands on to the memory, and some of the related instructions uh, to the related to the some of the other functions related to instructions. Then execution unit for uh, it is responsible for decoding and executing. So it contains some of the important units like ALU. Then the general purpose register is one of the most important units. Then status and control flags. These are all the things we have to include the execution unit. Now we shall discuss about detailedly for execution unit. This is for our the second part for execution unit. It contains ALU, general purpose register, then operands and the flag registers, then control system. Now go to next slide for the first one. What for take general purpose registers? All the registers for 16-bit in 8086. In 8086 it contains 8 general purpose registers, namely AX, BX, CX, DX, then set pointer, base pointer, source index, and destination index. So these are all the 8 16-bit registers. Then first one AX. So this is the accumulator, and it is a 16-bit register, and it divided into two 8-bit registers. One is AH, another one is AL. AH and AL, it has perform 8-bit instructions, but AX it performs 16-bit instructions. For AX generally used for arithmetical and logical instructions, but in 8086 microprocessor it not mandatory to have accumulator as the destination operand. So this is for first one for general purpose register. Next one BX. So BX means it is a base register. Uh, it is used to store value of the offset. So it has divided two 8-bit registers. One is BH and BL. And the BH and BL it is also to perform 8-bit instructions. So BX register to perform 16-bit instructions. BH and BL perform 8-bit instructions. Okay, next CX, that is a count register. So CX is a 16-bit register, and it is divided into two 8-bit registers, that is CH and CL. It is mainly used for looping and rotation instructions. Okay, the base instruction, the base register which is used to store value of offset, but in CX, that is a count register, is looping and mainly used for looping and rotations. Then DX, data register, which is also 16-bit register. It is divided into two parts, DH and DL. And DH and DL to perform 8-bit instructions. It is used for multiplication input and output port addressing. Okay, so these are all the four 16-bit registers. After that, stack pointer, it is also 16-bit register. Stack pointer, it is point to the topmost item of the stack. If the stack is empty, the stack pointer will be at the FFFE. Okay, that is the stack pointer is empty, so the address to be indicated, the stack pointer is always indicating FFFE. Okay, then base pointer BP. So this is the base pointer, which is a 16-bit register. It is primarily used for accessing parameters passed by the stack. Accessing parameters passed by the stack, which is the main purpose of base pointer. Then source index. This is source index register, SI for source index register, which is 16-bit register. It is used to the some string related operations. Okay, string related operations for using source index register. Similarly, for DI, destination index register, also using some string related instruction, which is 16-bit address. Okay, so these are all the 8 16-bit address which is available in general purpose register for 8086. Okay, next. Now detailed for the name and the description for AX. AX means it is a word multiply, for using word multiply, word divide, word IO, word input output. AL for 8-bit register, so that's why it is byte multiply, byte divide. AX is 16-bit register, that's why the word multiply and word divide. Then AH is also 8-bit register, so it is byte multiply and byte divide. BX store address information, that is offset informations. CX for string operations for like loops. Okay, then the CL for 8-bit register, variable shift and rotate instructions. DX for data register, which is available on multiplying and divide the instructions. Okay, so these are all the 8 16-bit registers. Okay, next. I told you what is the stack pointer, what is the base pointer, what is the destination index, source index. uh, the stack pointer, which is available in or which is accessed stack segment. The base pointer, which is primarily used to access data on the stack segment. Okay, then the source index register. Now I told you before, I told you what is source index. Source index is a 16-bit register which is required to some string operations. Similarly, for destination index register also, it is required some string operations. And then the string operation performed source register point to memory location, that is the starting address for associated with the data segments in the string operations, that is the data segment. Before that, in base pointer for stack segment, in the data, that is source index and destination index, which is accessed and addressed by the data segment register. Okay, then the destination index register is also addressed by extra segment registers. Because of the destination index register, it supports some string related operations which is addressed by extra segment register. Okay. So this is the some of the execution units. I explained only what is general purpose registers, what are the 8-bit and what are the 16-bit registers, what are the purpose of these 8-bit and 16-bit registers. I explained detailedly. In the next video for explaining status signals, status registers. Okay, thank you, students.